Okay, so let's take a look at another question. This one comes from the 2023 HSC Standard 2 Maths paper. This is question 34 in this paper. This also appears in the Advanced Maths paper. This is question 18 in the Advanced Maths paper. So the marking and the answer will be exactly identical to both. So a university uses gas to heat its buildings. Over a period of 10 weekdays during winter, the gas used each day was measured in megawatts, and the average outside temperature each day was recorded in degrees Celsius. Use X as the average daily outside temperature and Y as the total daily gas usage. The equation of the least squares regression line was found. The equation of the regression line predicted that when the temperature is 0 degrees Celsius, the daily gas usage is 236 megawatts. The 10 temperatures measured were 0, 0, 0, 2, 5, 7, 8, 9, 9, 10. Total gas usage for the 10 weekdays was 1840 megawatts. In any bivariate dataset, the least square regression line passes through the point x bar, y bar, where x bar is the sample mean of the x values and y bar is the sample mean of the y values. Using the information provided, plot the point x bar, y bar and the y-intercept of the least square regression line on the grid. Okay. So this is an absolute essay of a question. So for part A, we have our daily gas usage grid. We want to plot x bar, y bar, and we want to plot the least squares line. So first we need to find x bar and y bar, and we have to be careful to identify them correctly. So we are told that regression line predicts when the temperature is 0, the gas usage is 236. This means X is the temperature and Y is the gas usage. We're told the 10 temperatures, so we can find an average of these temperatures. X bar is going to be 0 plus 0 plus 0 plus 2 plus 5 plus 7 plus 8 plus 9 plus 9 plus 10 divided by 10. So this will tell us x bar is 2 plus 5 is 7, plus 7 is 14, plus 8 is 22, plus 2 lots of 9 is 40, so that's 50 on 10, that's 5. So the average temperature was 5 degrees. Total gas usage for the 10 weekdays was 1840, so this means y bar is going to be 1840 divided by 10. So this tells us that y bar is equal to 184 megawatts on average were used per day. So now we've got the x bar, the y bar. So let's reproduce our graph. It goes up to 10, got 8, 6, 4, 2, 0. This starts at 160, so this is an unscaled graph in a sense. This is 240, in between we've got about 200, then we've got 220, and then we've got 180. So this y is the megawatts used, and x is the temperature, degrees Celsius. So we're going to plot 5, 184. So we've got 5 here, we've got 184, it's about here. So we'll trace these across. So this is our point here. We also know that the equation of the regression line passes through 236 on the y-axis. So 236 is about here, up here. So our line of best fit, I can use my little ruler tool here, sort of passes through these points. It's going to be something like this. This is an approximate line of best fit. So plot the y-intercept and the least squares regression. This is our answer to part A. Now we have some more parts of this. We have parts B and C. So part B says, what is the equation of the regression line? Well, we know 2 points it passes through. It passes through 0, 236, and it passes through the point 5, 184. So we can find the slope. We know the y-intercept is 236. So B is 236. All we need is the slope. So that's going to be the rise over the run. The rise in this triangle will be this value. So 184 up to 236, that is going to be 16 plus 36, which will be 52. The run will be from 0 to 5, which is 5. So our slope m will be 52 on 5, but it's going to be negative because it's going downwards. And this, my calculator will tell me, is something like 10.4, minus 10.4. So minus 52 on 5 is minus 10.4. Minus 10.4. So therefore the equation for the regression line is y equals minus 10.4 times x plus 236. This is where we are using y and x as the values for the axes as opposed to megawatts of degrees Celsius. You could have variance on this form of the solution depending on what you called x and y. But this is the answer to part B. Now part C says, in the context of the dataset, identify one problem with using the regression line to predict gas usage when the average outside temperature is 23 degrees Celsius. So this line of best fit really only works for temperatures from about 0 up to about 8. So the line of best fit really only interpolates data if the temperature is from 0 to about 8. Right, so this is the range of values that you can sort of use this line for. 23 degrees Celsius is way outside of this. So trying to get the line of best fit to extrapolate data for 23 is not necessarily going to work. We could also plug this value in, and we would find that y equals minus 10.4 times 23 plus 236 is going to give us a really low value. So minus 10.4 times 23 plus 236, it's actually a negative value. It's minus 3.2. Remember, this is in megawatts, right? This is a negative number of megawatts. So this is not possible. You can't have negative gas usage. This model A only works for positive uses of gas. B only really interpolates, gives you strong data when you're interpolating, and that means you have to be between sort of 0 and 8, roughly speaking. Could be a little higher, a little lower. It may still work for those values, but 23 is too far outside of that range. And also 23 gives us a negative value, which is impossible, right? So definitely doesn't work for 23. So let's go through the marking. So for part A, you get 1 mark for calculating either x bar or y bar. So if you get one of these values, you get 1 mark. If you get the other value, you get the other mark. You get a second mark for calculating both of them and plotting them on the grid. So x bar and y bar and plotting that point. You get the third mark for correctly plotting both points on the grid. So this is the intercept point and this extra point. So if you have all of this, you get 3 marks for the first, for part A. Now for part B, you get 1 mark for finding the slope of the regression line or some equivalent. So minus 10.4 here will get you 1 mark. You get a second mark for finding the correct line of best fit. And then for part C, you get 1 mark for a correct justification for why you can't use this line of best fit for a temperature of 23. So something like the extrapolation is too far out of the reasonable range, 23 gives a negative value, some other commentary on why it's not viable will get you the 1 mark. So this is how we do this question from this paper.